At this point, I would like to introduce our next speaker, Shai Cohen from proteanTecs. Shai is an entrepreneur and industry veteran with vast experience in building technology companies from the ground up. Prior to founding proteanTecs, Shai co-founded Mellanox, a global leader of end-to-end InfiniBand and Ethernet interconnect solutions for servers and storage. He served as a Mellanox Chief Operating Officer, and before that, as VP of Operations and Engineering. At Mellanox, Shai oversaw.
I found this on the web for he served as a Mellanox.
I'm sorry, the Apple computer worked too well. So he served as Mellanox Chief Operating Officer, and before that as VP of Operations and Engineering. While at Mellanox, Shai oversaw all internal operations and production and co-led the company's research and development activities. He served as a member of the Mellanox Board of Directors from 2015 to 2018. With his leadership, Mellanox was successfully acquired by NVIDIA. Before Mellanox, Shai worked at Intel Corporation, like our previous speaker, where he was senior staff member in the Pentium processors and the circuit design manager in the cache controller group. Shai holds a Bachelor of Science cum laude in electrical engineering from the Israel Institute of Technology, or Technion. So ladies and gentlemen, please enjoy the presentation from Shai Cohen.
Hello and good afternoon, everyone. And thank you, Caspar, for having me today. My name is Shai Cohen, and I'm a founder and the CEO of proteanTecs, a deep data company. I'm here today to speak about a new approach to health and performance monitoring of advanced electronics, from production to the field. We currently serve the data center, automotive, and communication markets with customers ranging from chip vendors to system OEMs and hyperscalers. So why exactly do we need deep data monitoring? Well, the approach up until now has been based on risk aversion, and we can see this end-to-end at every stage. While it's natural to prefer certainty to uncertainty, the way the industry is achieving it is no longer scalable, especially as risks keep adding up. High guard bands being designed in to provide safe performance margins, worst case and iterative testing with a strict pass-fail mindset, high reliance on warranties and liability. All of these put a strain on the economics of manufacturers. Reaching the market fast with competitive, high quality, high performance products is becoming complicated, to say the least. And after deployment, once again, everything is planned for the worst case. There are increasing hardware redundancies, preventive maintenance cycles, high equipment replacement rates, all of these meant to assure service uptime without disruption. But this approach is no longer scalable. Let's take a closer look at why that is. We're talking about application markets that are mission critical, uptime critical, and safety critical. Data centers, automotive, and communication, all of these markets are transitioning to as-a-service business models. They have zero tolerance for unplanned downtime or errors and require extremely high performance, low power, and increasing functionality. So manufacturers are introducing super advanced technologies to enable this. We're talking about sophisticated architectures, complex designs, shrinking process technologies, heterogeneous packaging, and more. All of these create new challenges in the industry. Quality and reliability are harder to achieve, especially without giving up performance or competitiveness. Costs are rising, and mainly there is a lack of visibility throughout the life cycle. Add to this the very fragmented value chain with data silos in and between the different stages, and what we're seeing are new problems. We see very long development cycles, a huge dependency on product warranty, and if something does go wrong, an extremely high rate of no problem found, with an inconclusive and long root cause analysis. And at the end of the day, we also see problems and reliability issues in the field. I won't go much into this, but what you can see here is that the major players, the market leaders, are openly discussing these issues. We're hearing more and more from hyperscalers and OEMs about new issues that they encounter in the field, all stemming from undetected or latent manufacturing defects or issues that manifest in the field and are hard to predict and prevent. In the case of advanced electronics, system performance becomes a sensitive matter. Add to this the fact that certain parameters will change after extended use, especially given application stress and environmental effects, and you have the recipe for issues that can be as difficult to pinpoint as they are costly to endure. In some cases, these errors happen in a way that cannot immediately be detected or flagged. Sometimes a calculation will give the wrong result. Other times, an instruction doesn't behave exactly as it should. In certain cases, the error is inconsistent, making it even more difficult to find. These service providers want for their systems to be able to recognize these errors and report them. It would be even better if they could be predicted. Imagine that you could see the actual performance margins of the electronics while the application is running and act on it. That's why we're introducing a new approach. proteanTecs has developed a way to provide end-to-end visibility based on deep data analytics. With this new technology, which I'll describe in detail in the next slide, manufacturer and service providers gain a new understanding of design, production, system, applications, and environmental issues throughout the life cycle of the system. We're giving chips the ability to report their own health and performance so that at every stage, users realize great benefits. During product bring-up and volume testing, chips and system vendors can reduce defected part per millions by 10x, optimize power performance per application, improve performance yield, optimize and track reliability margins, and significantly shorten time to market. Once deployed in the field, service providers can be alerted on faults before failures, significantly lower maintenance costs, optimizing system performance, reduce return material, optimize fleet management, and extend product lifetime. The technology is comprised of several key pillars. First and foremost is the deep data generation. We've developed universal chip telemetry, or UCT, which provides on-chip monitoring based on agents that are built for analytics. These UCT agents operate in both test and mission modes and provide extremely high coverage for key parameters at every stage. They are strategically placed during design using automated insertion tools after a thorough analysis of the design and process technology. Measurements from the agents are extracted and uploaded to a software platform for data fusion and domain-infused machine learning inference. At the end of the day, our customers get advanced analytics with actionable insights and alerts on cloud-based platform for continuous health and performance monitoring. Here you can see a bit more details about the UCT agents. As I said, they are built for analytics, which is what allows them to be very small and widespread, having negligible impact on power, performance, or area. They are sensitive to many vital parameters in the chip and can sense both issues in the chip as well as the surrounding electronics, application effects, and environmental impact. They operate in mission mode, so you don't need to put the device in test mode or stop the system operation. We categorize the agents into 4 types. Design profiling and process classification agents, which provide fine-grained visibility of the full distribution at every stage. These determine if the issue is by design or a product of process variability. They provide visibility into on-die variation for process speed, leakage, RC delay, path delay, and more. The performance and degradation agents provide visibility of the timing margins at every strategic location in the chip for millions of paths. The margin agents monitor performance and performance degradation at every stage, from characterization, qualification, volume testing, and during lifetime operation in the field. With these agents, users can also see not only where they have scarce margins, but also where they might have excess margin that they can tune down. They can exploit this extra margin to push the limits even more by increasing frequency or reducing voltage to save power, for instance. The operational agents provide deep visibility of system, software, and environmental issues as seen from the chip, as well as diagnostics as to the root cause of the problems, if they stem from application, system, or environmental effects. This is a great tool for both debugging in production as well as lifetime monitor in the field. And the last category of agents are the interconnect performance monitoring agents, which provides visibility of interconnect in advanced packaging technologies. Users can see the actual performance per pin and on either side of the connection. Not only that, they have grading, not just pass-fail, so they can be used for performance optimization and useful life extension. So that was an overview of the agents. And now I'd just like to briefly discuss the platform itself, which is called Proteus. Proteus is an enterprise software for cloud and edge analytics. It is cloud agnostic and built for scale. It comes with built-in, out-of-the-box algorithms and analytics for the various life cycle stages, but it's also open for innovation. We offer a robust development environment for customized algorithms and analytics. Proteus is also open for integration of additional data sources, both customer data as well as third-party vendor data. We accommodate data import to enhance the analytics and provide a comprehensive monitoring solution, including automated action deployment to the customer's edge software with API integration. Proteus is also actionable at the edge, for example, on the test floor for real-time decision-making. Here you can see just a snapshot of some of the analytics Proteus provides. As you can see, it provides targeted solution for every stage of the life cycle, from chip production to system production to lifetime operation. In chip production, we have analytics for faster characterization and qualification with higher confidence, advanced outlier detection for lower defected parts per million, early and fine binning, early detection of production shifts and drifts, test time reduction, and much more. In system production, there are analytics for cross-stage correlation, power optimization, system and application optimization, and fast root cause analysis. And in the field, Proteus provides analytics for degradation and performance monitoring, alerts on faults for predictive maintenance, functional safety, degradation monitoring, and reduced return material with pinpoint resolution. These are just a few examples of the wealth of data and insights Proteus provides. Since UCT is applied at every stage, starting from chip qualification and volume production, through to system integration and optimization, and then to in-field operation, it creates a baseline of common data sets throughout the industry. This provides backwards and forward correlations, insights, and predictions, and for the first, creates a common data language for the value chain. And just a quick word about the company. proteanTecs was founded by me and several partners in 2017. Evelyn Landman, our CTO, Ronnie Ashuri, our COO, and myself were all co-founders of Mellanox, now NVIDIA. After many years in the industry, making chips and systems and witnessing firsthand the industry's inherent challenges, we have set out to address some of those challenges with proteanTecs. I'm proud to say that after 4 years, we have customers in some of the highest growing segments in the electronics industry. We have 140 employees located globally with offices in Israel, in the Bay Area, New Jersey, Taiwan, India, and Germany. And we're backed by some of the leading investors in the electronics and SaaS industries. I'm happy to share that we've recently closed a strategic extension of our growth equity round. 2 weeks ago, we announced the addition of Porsche SE, MediaTek, and Advantest to our investor portfolio, each one being a market leader in their own industry vertical. As I mentioned, proteanTecs is already serving leading electronics vendors across multiple industries, including data center, cloud computing, automotive, AI, and communications. We serve first-tier customers for chips that include AI, switches, servers, storage, HPC, communications, and ECUs. So that brings me to the end of my presentation. Thank you again for having me here today, and feel free to reach out if you have any questions. Thank you, and have a great day.
Well, we thank Shai Cohen. He is based in Israel, and so this is after midnight his time. So for the Q&A session, we would like to invite proteanTecs Vice President of Worldwide Field Engineering, Krishna. Krishna, are you online? Can you join us? Let's give Krishna just a few seconds here. And Alex, you may need to look for him and give him the spotlight. Alex, you may want to unmute Krishna Adusumali.
Yeah, hi. I was interesting. Thanks again, William, for first of all having me over. More importantly, this is a very definitely a STEAM conference, and I would definitely looking forward for the next conference, hopefully in person, when we are out of all this pandemic situation. But thanks again for having me over, and yes, go ahead with your questions, and hopefully you'll start with an easy one.
Sure. Well, it's you know, we all have heard something about engineers in Israel, right? They're smart, work hard, and can be a bit of confrontational at times, but for good reasons, right? what is your experience working for an Israeli company?
Well, it's actually timely you asked me. Just a couple of months back, I had an opportunity to visit Israel. Also, it's my first time visiting Israel. So the good and bad, right? The good thing is they actually have more of holidays than combined with India and China together. So I was just like it's an exaggeration, but they definitely have a lot of holidays there, which is good. The other thing is also I found most of the Israelis are actually, when you meet them in person, they're really, really good. They have a great sense of humor. More importantly, the hospitality is amazing and second to none. I mean, I think they are pretty proud of their culture. And more importantly, I think they make you feel at home when you go there, and they find a way, go out, bit out of way as well to make sure that you go visit the places of interest while you're there. So all in all, I think it's a great place to go, good people to work with. Yeah, the constructive confrontations, that's actually also part of the cultures which I grew up. I spent a good amount of time working at Intel, so they encourage that as well. So it's something only good has to come out of that. So that's a good question.
Great. Well, thanks. Although you and I work in the same company, it's refreshing to hear your opinion. Good. So later on in this program, we actually going to have a panel discussion, and they're going to talk about, of course, one of the hottest topics of the day about supply constraint or supply shortage. How do you see proteanTecs technology help to address the global chip shortage?
Right. I think it's a very timely question, and this seems to be the topic which is resonating in multiple different conferences, panels, and more importantly, our day-to-day lives as well. I mean, I can just give you a quick example of how it impacted me. I'm done with my 3-year lease with one of the cars, and I'm really struggling actually to get a car because one, it's a huge markup prices on the car itself, and two, even if someone is willing to pay that markup price over MSRP, the cars are not available. So it's definitely impacting day-to-day lives, and I think it's a timely question you asked. The way how I look at it, how Proteus is again the software, the platform, the data analytics platform, which combined with the UCT. UCT is nothing but it's a trademark. It's nothing but providing chip telemetry. Now this is very unique, innovative compared to if you go talk to any of system players like the hyperscalers and the system companies today. Network telemetry is something which is pretty common, and they heavily use it. It's day-to-day for their life. It is the first time, I think it's time, given the fact that the advent of the advanced nodes and the rising costs of manufacturing these chips, it's only inevitable that we need to provide this kind of telemetry or chip telemetry, right? Which not only just detects and provides this telemetry data, but also certain algorithms and intelligence built into it, which will help the system companies, the hardware companies, the automotive companies to take advantage of and come up with some predictive maintenance or detect certain failures. Now let me circle this back into how does it play into the global chip shortage, right? First of all, I think Proteus, which is our the platform, it provides many benefits to manufacturers and service providers. So the way how it provides is in two different ways, right? One is first, it allows for early detection of production shifts and drifts, which saves unnecessary loss of good yield. So think about like performance yield, right? And the way how it provides is providing these deep data coupled with some intelligent machine learning algorithms that helps you to come up with a stage-to-stage correlation across the life cycle of the silicon stages. Think about from a NPI all the way down to the in-field. And that visibility, which is the visibility of the millions of path margins in your chip, right? That helps to provide the telemetry data provides you the stage-to-stage correlation, which can help you to debug any production drifts or any issues up front. So that means you're optimizing the life cycle. So that means you're squeezing in the ability to get the system out of the door, not the tape out, but the system out of the door quickly. The second thing is also it helps to shortens the time to market because of two things. One is once you're done with the tape out, the silicon is back. From that time onwards, there's a good amount of time every company spends to get the chip out of the door or the system out of the door. So there are certain stages we need to, if you can optimize those stages by providing some test time reduction, by providing a much better predictable outlier detection algorithm to to wean out any issues up front, that's directly translating into shortening the time to market, which can also meet the demand sooner. So I think there are these are a couple of ways, because this deep data, telemetry data, will help in optimizing these stages, coupled with providing these kind of reliability, extended product lifetimes with the the degradation data what we provide, both from a performance as well as reliability, can help to extend the useful life, which will also help us to reduce the hardware replacements or RMAs. So they all play into the part for improving the situation with respect to the chip shortages.
Great. We sure hope more people will pick up that solution so that this shortage will be gone soon. Shai mentioned in his presentation DPPM reduction, right? Is defects per parts per million parts. What is unique about the proteanTecs solution, especially compared to the existing methods?
Yeah, so I think it's a good question too. I can so I have a first-hand experience of this situation with working with some of our hyperscale customers, right? So one of the situations what we have seen, the best-known methods, I think some of them, I think we traditionally call that as part average testing. So if I step back and give you some analogy at a high level, 10,000 feet high level, so it's a difference between a population medicine versus personalized medicine approach. When it's a population medicine, what does that mean? Like, you have a problem, you go in, you're gonna get an over-the-counter, medicine, or you have, you think based on the symptoms what you see, maybe you have this problem, go take this medication, move on. The good side of it, the bad side of that story is it might actually not even fix the issue what you are facing, because there's no personalized data which you are giving. When I say now compare that to a personalized data, what does it mean? That means you're taking the blood work, you're looking at all the vitals, looking at your body, your data, your analysis, your data, and then based on that analysis and data, you're actually providing a prescription, right, or a preventive medication, or some based on the real data. If I contrast that to the existing mechanisms that we have today, so the best known methods like the part average testing, those currently, that's what people use. Basically, it clearly defines a generic upper level and a lower level band, and then you generalize and you population based, your chips coming into population based data, and say you go fit in anyone which is not fitting this band, you basically throw it. It could be a good part, you're throwing it away, or sometimes it could be the other direction. So now what's happening, the way how Proteus, the platform, comes into the picture is because Proteus is now, with the deep data, telemetry data, which we talked about, or which Shai talked about as UCT, it's helping to come up with some more personalized outlier detection algorithms. When I say personalized, the platform comes with a learning outlier detection algorithm, which is personalized to that chip, that die, that chip, and the DNA of that particular chip. Now, what would that help us? It helps us to build a prediction model based on the measurements taken from the manufacturing set. So unlike the part average test, Proteus personalized outlier detection compares each new tested device to its own prediction, not to an absolute upper and a lower limit. So this helps us, two things. This helps us to make sure that we detect any of the issues up front, where it could be a potential RMA or potential issue which is left undetected. The second thing is it significantly also directly helps in reducing the DPPM without sacrificing any performance yield. So it's very personalized. It's personalized to your data, and the prediction algorithms and the models which are built is towards that personalized chip. And that itself helps us in making sure that it improve the DPPM while also making sure that improve the performance yield as part of that.
Oh, great. Yeah. So especially with the advanced process technology, right? N7, N5, moving down to 3
Okay.
nanometer, the variability, even on the same wafer, is getting more and more pronounced.
Right.
So that personalization become more and more important.
Absolutely.
Yeah, you can no longer use one yardstick to measure, everybody, right? So thank you for that. Lastly, can you provide a bit more details about how the software, and you mentioned Proteus is the name, can detect the faults in a chip while the system is in mission mode?
Definitely. I think if you hear Shai's video, where I think he repeatedly mentioned two things. One is we do all this telemetry data, we do all this analysis, and coming on a the system is in operation or in mission mode. So think about something like this. We are continuously monitoring with our UCT agents, right? And you're doing on-demand readout based on the systems what you're putting in place. So this is continuous. There's no special mechanism we need to come in and say, okay, now hold off your system, hold off your operations, get it down to certain tests, and then I'm going to do the readout and then come with some analysis. That's not the case. We're going to continuously monitoring, and the impact of our UCT agents on the chip design is very, very minimal. It's a negligible, or almost like a near to very, very negligible PPA penalty, because they're very small in footprint. It doesn't take a lot of real estate in the first place. It works on core VDD, and these are some of the uniqueness we bring as part of our UCT agents. Now, coming back to the question about how do we, how the software can detect faults, right, in the mission mode. So I think the first and foremost, these UCT agents, they monitor many effects, right, especially including performance and reliability degradation. Now, I think the key thing is to also think about is the in-field, during even in-field. A lot of times, if you see even the automotive sector today, so most of the times the reliability degradation or the performance degradation, there's no really closed loop coming from in-field all the way back into the system, right? So this is the innovation or the uniqueness Proteus brings in, where it connects the in-field degradation and reliability degradation and the performance degradation, build the predictive algorithms and extended useful life algorithms, and able to take the data in upfront, right? So now if I circle it back to this, so now the degradation can stem from many different areas, right? It could be coming from aging effects. It could be coming from an application stress due to a software update. It could be coming from other environmental system where the chip is sitting, right? Now, all of this is actually is captured. This data or these effects are captured through our UCT agents. They are fused. These different dimensions of data are fused into our analytics platform, and then we're able to actually build a predictable model, saying that, hey, based on what I see from your localized continuous monitoring data, we're able to come back, we're able to predict, saying like there will be a degradation happening from a margin level or from a reliability level, and that's where you are getting a heads up upfront. And this is what we were talking about, called as telemetry data, right? Now, this is actually the main thing is this is all done in mission mode, right? Without the need to stop the system operation or put it in a test maintenance mode, right? So for example, I can tell you with one of the use cases, some hyperscalers would like to know, I'm not worried about failure of a core on my data center or blade, but what I really care is give me a heads up so I can do a predictive maintenance, right? Give me a heads up, saying like, it will trigger me an alert saying at least 6 months before, 3 months before, however you configure the system, to tell that I'm going to have a problem here, so you better watch out now and take care of this. So this is exactly what predictive maintenance is all about. And this is, they're able to provide this level of insights and visibility along coupled with this data, which can help you to take these necessary actions and steps so that you are not really facing any downtimes or any challenges with respect to performance, also with respect to any performance degradation or reliability degradation.
Great. Yeah, it's about detecting degradations before degradations
Become failures.
turn into catastrophic failures. And this is all done in real time, negligible PPA, right? Power performance area penalties. So sounds great.
Right,
Wow.
and I do see some questions on the chat, so I will take a stab at that once we are done with this. So I apologize, I'm not responding you live, but I will get to this once I'm done with this.
You can only do a couple of things at a time. So I got it. So at this time, we'll let you take a break and respond to some of the questions in the chat room. Thank you, Krishna,
Thank you.
spend part of your Saturday with us.
No, thank you for having me again, and looking forward for the next year, hopefully.